Hi everyone, and welcome to this simple demonstration for you to show you why we need capacitors. What is the advantage of the capacitor as an energy storage element? So in this video, basically, we will have a voltage supply DC battery 10 volt. We have a resistance 100,000 ohm, and we have a 10 microfarad in series. So we have a switch as well to switch on and off our circuit. We have an ammeter to measure the current in the circuit, and we have a voltmeter to measure the voltage across the capacitor. So now I will run the simulation here, start running the simulation, and then still the switch is off, so there is no current, and the voltage across the capacitor is basically equal to zero. Now, the moment I turn the switch, please note the current, what happened to the current, and what is happening to this voltage. So now I will put the switch on. So the current goes to high value and now start to be reduced, and the voltage here is increased. Let me do this again another time. So basically, look to the voltage here, start from zero, and then it would start to go up until it reaches around the 10 volt. So the voltage here is around the same voltage as your supply, and the current basically is equal to zero. Why? Because the voltage here at the supply and the voltage at the capacitor are exactly the same. So basically, you will have no current because current goes whenever there is a potential difference. So when the capacitor here, we call it fully charged, is basically changed to an open circuit. When you don't have a current in the circuit, means the circuit is an open circuit. So here you keep on charging the capacitor until it is completely charged. Then there will be no flow of current, or the circuit convert to an open circuit. Now, if I remove the switch, open the switch, look here to the voltage is 9.9 volt. The capacitor has this advantage to hold the charge, hold the voltage. Why? To be used for another application. Now, what controls the speed of the charging of the capacitor? Let's do the following experiment. Let me come here and I will change the capacitor from 10 micro to 100 micro. So I will just come here and I will change the capacitor to 100 microfarad. And I want you to watch basically the speed of the charging. So click here. So this is the voltage that you have. Now I'll close the switch. See, the voltage becomes much slower than before. And the current even here decreases again. The voltage is increasing gradually, but the charging time is much less. So when I increase the C, the charging time, the time it takes for the capacitor to be charged has been increased a lot. Okay. Now, let me do another experiment and see the impact of changing the resistance. So I will come here, stop. I will put the capacitor back to 10 microfarad. Okay. But I will increase the resistance now. I will have it instead of 100,000. So I will add another zero, so it becomes 1 million. Okay, now let's see. Pause. Again, the charging is slow. So increasing the resistance or increasing the capacitance will slow down the charging of the capacitor, and hence reducing both, any of them also will reduce. This is, we call it the time constant, or the R times C, RC time for short. This is the time that is actually will govern the amount of the R, and the C will decide how short or how long it will take for the capacitor to be fully charged. So this is a very simple introduction about the capacitor charging, why we charge the capacitor, and what are the parameters that control the charging of the capacitor.